Hello there. In this video, which is going to be an introductory video to Matlab programming, in case you are not already familiar with Matlab and what it can do, this series will also be an introduction for those of you who may be interested in modeling or may be taking a class, say, on numerical methods or just using computers to solve math problems in general. So in this video, we're just going to introduce some basic syntax for some code and also go through how to display graphs in both 2 dimensions and 3 dimensions as well. Alright, so to begin, I will be programming mainly in scripts for the most part, at least for some of these introductory videos, because it's definitely a very comfortable place to work in, because you can sort of delete, save, move things around, comment things, and sort of treat it as a notebook in case you're still learning how to program, which is a little bit more easier to use in the command window, which can do basic things like 3 plus 2 and other arithmetic things if you need to. So what I've done here is I've created a script and I've called it Let's Learn Nemo, and it's of course an M file. So this function is not going to return anything to the console or the computer, so I'm going to pretty much be writing all of my code in this window. So the first couple of things that I want to do is I want to pretty much clear my workspace so that I don't have any other things that are sort of confuse me. So let us assume I have graphs that are already opened up. The function close all will close all the current graphs, and it will just open up whatever graphs I choose to run in this program. And also CLC will clear all the command window stuff because I don't want my workspace to be messy. So if I run this script, it will clear the command window and close all current figures and windows, but of course there's no windows to close, so no big deal there. Alright, so the first thing that I'm going to do is I'm going to graph a 2-dimensional graph like x squared, sine x, and so forth. So if you do a percent sign, anything that you write after it will be considered a comment. So anything that follows this percent sign, the compiler will not be able to read. So this is pretty much where you will include nodes. So I'm going to graph a function on the domain 0 to say 100. So what you can do is you can sort of create a set of numbers, say 0 to 100, that is spaced equally by some distance, say 0.01, and graph the y values at all of those x values. Because remember, in computers currently, there's no such thing as a continuous curve, it's just a real dense set of points. So I want to go from 0 to 100 in spaces of 0.01. So that will construct a vector, which has 101 times, or divided by 0.01, many points, and that will create my vector that I will use as my domain. So for my y value, what I'm going to do is I'm going to take all those x values, I'm going to take the cosine of those numbers, and then I'm going to multiply by, say, x squared. Then I'm going to add to it the sine of that value plus e to the power negative x. So this is just some basic syntax on some of the functions that we have. So exp to the negative x is e to the minus x, sine of x and cosine of x self-explanatory, and x squared is x caret key 2. Now why I am putting these dots here in front of the multiplication operator and the exponentiation operator is because we are multiplying the elements point-wisely. So the first element cosine times the first element's square value plus the first element's sine plus the first element's exponentiation, negative. In general, you do not need to put a dot in front of the plus, only for exponentiation and multiplication, and that's associated to the basic linear algebras of multiplication and these things. So that is also going to give me a vector in the y direction. So if I plot x versus y or y versus x, that should give me the graph. So what I want to do is open a figure, and I'm going to give this figure an ID number. So if I were to just run this script, the only thing it will do is construct these two vectors, do nothing with them, and open a figure. So once I push run, it opens this figure, which I titled figure 1. You can name this figure 10 if you want, and that's going to create a new figure named 10. So we're just going to go numerically and just call this 1. And we're not doing anything with this figure yet, but that's pretty much what this code does so far. So what I'm going to do is I'm going to plot x as the domain, y as the range, and I'm going to plot these in the form red dots, and you put that in single quotes. If you want blue dots, that would be b dot. If you want magenta dots, that would be m dot, and there's other color codes as well. So once I run this code, it will generate the plot of my graph. Now let's assume that we want to add a title to this graph as well. So what I can do is I can use the title command. So title, single quote. So this is the graph of the function f of x is equal to cosine of x, x squared plus sine of x plus e to the power minus x. And if you're familiar with LaTeX at all, Matlab can read some of the LaTeX style code. For example, this brace in terms of exponent will exponentiate everything in that brace as well. And let's also include the grid. Maybe we want the grid on there as well. So once we run this code, this will give us a grid line on our graph and also tell us what the name of this function is. So cosine x squared, sine x e minus x. And that's pretty much the basics of graphing in 2 dimensions. All right, so now what I want to sort of show you all is how to construct 3D graphs. So the dimension of a 3-dimensional graph is going to be a 2-dimensional domain x versus y. So for the x domain, so I'm going to create a comment. So this is the graph of a 3D curve. I guess I should call this the graph of a 2D curve as well. So I'm going to create the domain x to be -10 spaced out by 0.1 to 10. And I'm going to do the same for y. So you can either do y is equal to xx, or you can define it to explicitly be this value. Now, these are 2 vectors, so you sort of need to span these 2 vectors in all of the directions for which they have. So to do that, or to sort of take the cross product of these 2 vectors, is via a curve known as mesh grid. So mesh grid pretty much calculates the cross product of the vectors x, y, y, and creates a Cartesian product whose domain is x and whose domain is y. So this is pretty much the matrix representation for the domain in terms of x and y values. So the z-curve, or the function that I'm going to graph, is the following. Let's assume I want to graph x squared minus y squared. And let's add some wavy nature to it. So I'm going to do 10 times the sine of x times y. And note here that you do not need a dot in front of multiplication because 10 is a scalar, not a vector. So no dot is necessary there. And let's also add a singularity just for fun. So let's do 1 divided by x times y. So that's going to calculate my vectors x, y, and z. So then I'm going to open up a new figure. I'm going to call it figure 2 so it doesn't overlap with my other figure. And in order to graph in 3D in Matlab, you're going to use the surf command. So that's going to be surf x, y, z, and a color map will automatically be assigned to this, and of course there's other ways to change it later. Let's also include a title for this fun looking surface. So let's do, this is the graph of f of x comma y is equal to x squared minus y squared minus 10 sine xy plus, and let's do xy to the negative first. So the title looks pretty clean. And that is the program on how to graph 2D and 3D curves. So let's give this a run and make sure it works. So the first graph, of course, it generates is going to be the graph of our original 2-dimensional curve. So nothing new there. And our second curve is going to be this fun looking shape. So of course it is a saddle curve. That's pretty much the behavior of this x squared minus y squared representation. The negative 10 sine xy, of course, is creating this ripple behavior here. And this 1 over xy term is creating this singularity in this middle. So if you click this little thing, you can sort of rotate through this curve to sort of get an idea of what's going on underneath it, on top of it, and from whatever orientation you're interested in. And remember, as long as y is equal to 0 and x is equal to 0, this function does not exist. So along the x and y axis, then we're going to have some issues. And at 0, 0, of course, we're going to have a pole as well in the z direction. So that is just some basics associated to Matlab on how you write a basic script in Matlab, run it, and how to construct graphs in both 2 dimensions and 3 dimensions. Hope you enjoyed.